Hello. So today we'll discuss one AIME question. As I've told you earlier that a lot of time you'll find the similar kind of questions in CAT and ZAT examination, in fact in IFT also. So although in AIME there will be a lot of higher level questions, but we'll just discuss those questions which are required in CAT preparation and the other MBA examination preparation. So we'll directly peep to the question now. Right, so it's a modulus based question here. It's given if fx is equal to modulus of x minus p plus x minus 15 plus x minus p minus 15, where p lies between 0 to 15 exclusive of these two values. Determine the minimum value taken by fx for x in the interval x is less than or equal to 15 but greater than or equal to p. First thing is, let's identify the modulus part here. What does this value represent? If it's x minus p is nothing but the gap between x and p, right? Or else in terms of diagram, suppose if I'll draw it in a number line, I have value p available here, so x can be here and x can be here, right? So this gap is basically x minus p here, and this gap I can say is nothing but p minus x. In terms of modulus, I can represent this as a negative value, this is nothing but a positive value, but my distance between these 2 points will remain same, right? So x minus p always represents the gap between the 2 points x and p. So I have to utilize this information itself. Now according to this, I have 3 critical points available. If I'll draw it in a number line, it's given p is between 0 to 15. So suppose 0 is at this point. The first one is p, assuming p is at this point. Then 15 is greater than p, so let's consider 15 is at this point. And then it's p plus 15 basically, right? So obviously p plus 15 will be on this side, right? So I have just arranged them in ascending order, and according to the condition it says that x minus p, right? It says x minus p. So my possibilities are x can be anywhere. I can put x somewhere at this part, or else somewhere at this part, somewhere at this part, somewhere at this part, any of the parts, or else at the critical points also, right? So that's my possibility. So assuming that x is at this point, so this represents x minus p, this represents 15 minus x. In terms of modulus also I can say x minus 15, and this also represents it's x minus p minus 15 here, right? Assuming that these are nothing but the distance traveled, I am assuming that I have 3 friends available. They reside at p, 15 and p plus 15. Let's say these are nothing but the milestones, and 3 people are available at this point, and they have decided to meet each other. My condition is they have decided to meet each other so that they will travel a total of minimum distance possible, right? A total of minimum distance possible here. Now this total of minimum distance is nothing but the value of, so this total minimum or total distance here is nothing but f of x, as I'm just adding these displacements here, right? So since I want the total distance traveled to be minimum distance, I'll have to fix one person and I'll have to make the other 2% move. It's like you three friends have decided to meet each other, so might be possible that you will decide ki we'll meet at a point which is exactly in the middle, or else we'll meet at a person's house which is somewhere in the middle, so that only 2% have to travel and the third one can be resting at his house. So that's my relation here. So according to this, if we'll consider this fellow, let's say there is a fellow available here, he is traveling from this point to this point. Another person, let's say this distance is x for the time being, another person who is at this point, he'll travel from this point to this point, he'll travel a distance of y, and the third person is residing at this point itself, he is not moving at all. That will be the minimum distance traveled here. So I can say the minimum distance in this case is x plus y. Can we identify that this minimum distance is nothing but the gap between these 2 points, p and p plus 15? So it's nothing but the gap between these 2 points, which is nothing but p plus 15 minus p, or else we can say 15 will be the value possible. So my minimum distance possible will be nothing but 15. So let's not consider this one as a modulus part, let's consider this one as a normal distance formula and distance format, and we'll just apply the basics of distance in these cases. So I can always solve the modulus question with the help of arithmetic. So that's all for today. Thanks for joining us.